In the last two videos on matter, we talked about solids, liquids, and gases as being the three states of matter. We largely said that the intermolecular forces essentially determined that they were solid, liquids, or gases. We also then explored the reasons, uh, phenomena like surface tension, the pressure volume relationship, as well as heat transfer modes like convection and conduction exist because of the difference in intermolecular forces between these three states of matter. I think the obvious next question is, if there are three states of matter, is it possible to transform matter between these three states? That's between solids, liquids, and gases. And the reality, yes, is yes. For example, take water. Water exists as water, which is the liquid form at room temperature, as we see in most places. Of course, also exists as ice inside a refrigerator, or of course in colder countries where you have in the form of snow and so on. And when you do put it on a kettle and kind of boil it off, it disappears into a gas called steam. So essentially, water can exist in all three states of matter, which is solid as ice, liquid as water as we know it, and as gas in the form of steam. The reality is, chemically, it always remains H2O, which is two atoms of hydrogen and one atom of oxygen, making one molecule of H2O, which is a water molecule. The reason I state that is the states of matter are basically only physical manifestations. In some sense, the matter remains the same and is not chemically modified when it transforms from one state of matter to other. For example, metals, when heated, tend to flow, and then they are recast into different shapes and so on and so on. That's a transformation. Let's say something like iron from a solid to a liquid, where it is cast into a shape and then it's solidified back again into a solid metal piece, but of a different shape. It's of course also possible to vaporize it, but the question is, do you really see it around to see that it gets vaporized? You do see in volcano and so on, the temperatures become so high that some of the even metals kind of reach a vapor state. But I think water remains the example that remains closest in terms of transforming from a solid state to a liquid state and a gaseous state. Now we know that the most common way to do this from ice to water to steam is to apply heat. Heat is essentially just a form of energy. It's the energy that is a driving force for state change between solid, liquid, and gas. So, for example, take ice, which is a solid, and begin to apply heat to it. What really happens is, at a temperature where it is ice, which is below 0 degrees centigrade, as you apply heat, the temperature begins to rise. And at 0 degrees centigrade, as you apply more heat, the temperature does not change, but after some time, it begins to melt and become water. Then, as you continue to apply more heat, the temperature again begins to rise. And as the temperature begins to rise, it goes to 10, 20, 30, 40, 50. And as it goes to 100 degrees centigrade, then as you apply more heat, the temperature remains static at 100 for some time before it vaporizes into steam. Now, why do we see those moments where the temperature does not change, but the change of state happens? That's because energy can do two things to matter. The first thing that it can do is, of course, increase its temperature, and that's what it does. But it's not just a temperature change that leads to a state change from either from a solid to a liquid at 0 degrees centigrade for water, or from a liquid to steam at 100 degrees centigrade. There is more amount of energy required to alter the state of matter. Like I told you, in solid the intermolecular forces are very strong. There is energy required to make the intermolecular forces seem smaller, or in comparison, increase the external heat that you are providing so that you overcome that internal molecular forces and change them into a liquid state. Similarly, at 100 degrees centigrade, the same thing happens. For some time, all the energy that you are supplying is for overcoming those intermolecular forces that become more loose and then become a gas. So therefore, if you look at the phenomena and purely as definition, the movement of a matter, a state of matter from a solid to a liquid is called melting or fusion. And vice versa, if it's going from a liquid to a solid, it's called freezing. So those are definitions you are fairly familiar with. Similarly, when matter goes from a liquid to a gas or a vapor, that process is called vaporization. And when the reverse happens, that you get steam and it kind of falls back into a liquid, that process is called condensation. So I think the processes to remember are very simple. Take ice, it melts or fuses into water, it vaporizes into steam, it condenses back into water and freezes back into ice. So that's essentially the process. The temperatures at which this transition happens are called melting point when it is going from a solid to a liquid. Therefore, the melting point of ice is 0 degrees centigrade. And then the point at which the liquid vaporizes is called the boiling point, or also sometimes referred to by different name, but essentially boiling point is the name that's given to it. And that temperature is essentially when at boiling point the liquid transforms or vaporizes into a gas. Coming back in, the point at which the temperature at which the gaseous state transforms into a liquid state is called the condensation point. And similarly, when the liquid state goes into the solid state, it's called the freezing point. So those are essentially typical temperatures at which this happens. I also told you that the energy that you supply, while it increases temperature, there's a moment where energy is being absorbed into the system, but the temperature is not increasing, and all that energy is used for change of state. Therefore, you also have two other properties which are called latent heat. The reason it is called latent basically means hidden. The reason it is called latent heat is because you typically, when you apply heat, you see the temperature changing. But somewhere when the temperature doesn't change, you feel that all that energy that you're supplying is going and hiding somewhere into that material. That's why it's called latent heat. So there's a latent heat of fusion when things go from a solid to a liquid, and the additional energy that you need to supply to take it from that solid state to a liquid state without a change in temperature, because it's all happening at one temperature, which is the melting point, is called the latent heat of fusion. Similarly, the heat that you need to apply to water at 100 degrees centigrade, keeping it at 100 degrees centigrade to transform it into steam at 100 degrees centigrade, is called the latent heat of vaporization. Now, the latent heat is essentially energy that needs to be given to the system so that the intermolecular forces are beaten, and from a tightly packed solid it becomes a looser liquid, or from a loosely held liquid it actually becomes a gas. So therefore, that's the energy you supply. But like all things about energy that's mostly conserved, you also can retrieve this energy back when you go in the reverse direction. So for example, you do get the latent heat of fusion back when you are going from liquid to solid, or when you are condensing from a steam to a liquid state. Now you see many phenomena around you, very weather-based phenomena around you, where you begin to notice the latent heat of fusion and latent heat of vaporization. On days that has been snowing, it actually feels a little bit warmer, because in the process of the snow melting, it needs to take away heat and therefore feels cooler, and vice versa. There are many examples that are given in textbooks, but I think as long as you understand these concepts, you will be able to comprehend what latent heat is, what boiling points are, what melting points are, and essentially the whole idea that it's simply energy being put into a system that can transform it from a solid to a liquid to a gas, because gases are very loosely held. So what was solid was very strongly held. You need to break that structure that is holding it together, so you need to supply energy. So if you simply look at it from an energy perspective and knowing intermolecular forces and understanding that intermolecular forces are very strong in solid and very weak in liquids, you see that it's simply an interplay of energy that needs to be given to a system to go from solid to a liquid to a gas, and the energy can be recovered when the system comes back in from a liquid, from a gas to a liquid and to a solid. If that point is made, I think it will be much easier for you to understand the states of matter and the fact that it's simply a physical transformation, which is simply an exchange of energy between that matter and what you apply externally. We, of course, most cases apply it as heat, but there are many other ways to transform matter through just giving energy. Heat being just one of those processes. Thank you for your time.